poke my head around. Hi, I'm Dan. I like to fix things. So today, what we're working on is not repair so much as building something. I sold my Class C motorhome because it was too big, took too much gas, and at 8 feet wide, it was too wide for the mountain roads I like going on. So I bought a Ford Transit cargo van, and it's a 15-passenger van, and I'm converting it into a camper. Of course, an important part of a camper is to have an electrical system so that you can have things like a refrigerator and a stove if you want one. My wife likes to have a hair dryer and a straightening iron. So for that, we need some power. To accommodate that much power, I've installed two 100-amp batteries. These are from Lifetime. It seems to be a good company from what I can tell. I bought these with my own money. I'm not getting paid for this, but if they want to pay me, well, send me some money. But I don't think they're going to. I installed these right here because this is one of the least useful places in the van, and they're a perfect fit. So these are 100 amp hour batteries. I'm going to install them in parallel. When you install batteries in parallel, your voltage stays the same at 12.8 volts, but you add the amperage together. So we're going to have 200 amps at 12 volts, and that's going to give us enough power for a good sized refrigerator, hopefully, and the other things that we need. Now, I worked for 17 years as a communications technician for the telephone company, so I know my way around AC and DC current pretty well. I've never worked with stuff like this before. This is the size of the wire. It's about I have fairly large hands. It's about the size of my little finger. It's pretty thick wire. To handle 200 amps of current, you need a wire size that's 2/0. Or some people call it 2/0, or 2/0 is how you'll see it in writing. This 2/0 wire can handle 200 amps. And to wire things in parallel, you go from the positive to the positive of the two batteries, and from the negative to the negative of the two batteries. And then you bring the power off of one battery. I put a 200 amp fuse in here, so if we have any short circuits anywhere, it'll blow the fuse instead of blowing up my very expensive batteries. And so the positive is going to come off of this fuse like this. The negative will come off of this battery. When you're wiring these, you want to bring the positive off of one battery and the negative off of the other battery so that the batteries stay balanced. Otherwise, over time, one battery will get charged less than the other. Going to create problems you don't want. Now, I've never done this before. This involved cutting the cable with some nice cable cutters that came in the kit that I bought, and then crimping it. You have to crimp the ends onto it. So I crimped the terminal ends, and I used this wonderful hydraulic tool. It's from a company called AMZ CNC. I'm not going to try to pronounce that, but this is a crimping tool. It has different size dies, so it can, let's see, 1, 2, 3, 4, 5. It has 8 different sizes of dies, so it'll do 8 different sizes of wire. The largest of which being the 2/0 wire that I have. I did run into one problem. When I use the 2/0 die that comes in here, these dies look like this. They slip in and out. That's what the dies look like. Okay. So the dies slip in and out of the machine. And put the wire, slip the terminal in there and crimp it. The problem I ran into, this wire is very flexible. The individual wires in this are very thin. This makes it more flexible than most 2-aught wiring. So it's really great wire, but the crimper would not crimp down hard enough with the 2-aught. So I moved to the next size die. This die says it's a 1-aught die, also called the number 50. So by going to the next smaller die, I was able to get this nicely crimped. You want to pull on these hard after you do it. If it slips off, it's going to make a mess, but not as big a mess as if you don't pull it and it's loose. Also, when you're making these, like this needs to be flat. So we're going from here to here. We have to be careful to touch the positive to the positive. If we accidentally touch the positive to the negative, we're going to transfer 100 amps of power. If I touched right here right now, 100 amps of power would shoot this through this battery. Bad things would happen, probably destroy the battery. Might destroy me, I don't know, but I'm not going to find out. So we're going positive to positive. So I created this one first, so it's going to go on here like this, going to connect to the fuse, connect it here. Of course, you want to torque these down, and the battery company will tell you the torque spec on this, but you want to torque these to specification so you have a firm connection. The rule when working on electricity is a good mechanical connection makes a good electrical connection. So anytime you're working with electricity, make that be your motto. A good mechanical connection makes a good electrical connection. Good rule to live by, among others. Now, I haven't finished this job. I'm going to take this back off because I don't want any shorts to happen. There's heat shrink tubing on here. I haven't heat shrunk it yet, but I'm going to put this right up to the edge of the bolt like this. And then I happen to have a heat gun, so I'm going to use a heat gun. If you don't have a heat gun, you can try a cigarette lighter or a hair dryer on high. But this is heat shrink tubing. You need to put this on before you crimp anything down. Bring it right up to the edge, and when you heat shrink it, then that's going to provide a non-conductive surface to lessen the chance of any shorts. Also, since we're going flat to flat here, we want this to be flat and this to be flat. It's important to consider the angle. So if you're going flat to flat, what I did was put it down on the ground, it made it nice and flat, and then I marked the insulation and I marked the terminal so that when I crimped it, I made sure these two lines lined up so that I had my flat to flat angle. There may be occasions when you have a different angle than flat to flat, but whatever the angle is that you want, make a mark and line it up first. Make sure it's right first. And that little mark is going to help you out by showing you what your angle is. So let's take a look at what I had to do to achieve this. I started off with a 5-foot piece of 2-aught cable. And before I even go any further, I'm going to go ahead and take the heat shrink. I'm going to need one for each end. So I'm going to slip this piece of heat shrink over. And we'll slip this other piece of heat shrink. It's easier to do this before you cut it because, as I mentioned, there's a lot of wires in there. These wires are very fine. Don't know how close I can get so you can see that. But after I cut it, you'll see how fine the wires are. And also how thick this is compared to my pinky finger. So the heat shrink's on. It's cut. So the next step is deciding how deep to cut the insulation off. You're going to need to remove the insulation. So right about there is about as far as you're going to be able to push the insulation in. I'm going to take a razor knife. A one-handed one works nicely. I'm going to cut around the insulation, but we're not going to cut too deep. We don't want to cut any of the wires, and we don't want to cut ourselves. So there's a lot to be careful about here. I'm going to go ahead and make a cut lengthwise. That's going to make it come off easier when we get deep enough. So, getting the razor knife. They do make specialized strippers for that, and if you're just floating in money, or if you're going to do a lot of these, if I were doing this job multiple times, I would invest in the right tools for it. But the razor knife with a sharp blade is right enough. Trimming here. This is taking a little while because I'm being very careful. I don't want to cut this. Now, there's a paper insulation. Sometimes the paper insulation comes off with the rubber insulation. Sometimes it doesn't. So we'll just trim that. We'll get that out of the way. And now, if you can see, I'll spread these out just a little bit. So you can see these are very fine wires. And this makes this 2-aught wire more flexible than I think a lot of it is. Now, these terminals for 2-aught come in two different sizes. They both fit the same wire. They both fit the same wire size, but one of these is marked 2-aught 3/8. One of it's marked 2-aught 5/16. Okay, some of the terminals that you may run across when you're doing your full install may have 3/8 terminals, and you'll need one of these. Others have 5/16. These Lifetime batteries have 5/16 terminals. Here's the bolt that goes through. That fits through, and it's a nice snug fit. When I put it through the 3/8, that's a loose fit, okay? And what's our motto? A good mechanical connection makes a good electrical connection. So we want to try to make sure that we have the right mechanical connection by using the right size terminal to match our bolt size. There's only two sizes, not too confusing. So I selected a 5/16. The wire's cut. It's trimmed back. I still have a little tiny bit of paper there. Let's get rid of that little bit of paper, because that paper is a little less conductive than copper. And do notice this is pure copper wire. They make aluminum wire in this gauge, but it's not as conductive. It's prone to overheating. I would not even consider using aluminum wire for anything. There we go. So heat shrink on before I put this on. And okay, that's a nice fit. It goes up in there. Now we're going to take our hydraulic tool. This isn't the only way to do it. For about $15, you can buy something that has dies, and you whack it with a big hammer. And I've never used one. They probably work, but I wanted to make sure this was done right. So I have the smaller die in there. I have a 1-aught die instead of a 2-aught die because when I used this with the 2-aught die, it was still loose. I could pull it right off. I think the reason that, so the three possibilities would be the die's wrong. I don't think that's the case. The terminal maybe isn't as thick as normal. I don't think that's the case either. I think the reason the 2-aught die didn't work with this wire is because the wire has so many strands, and it's just a softer wire than standard. But that makes it more flexible. So this tool it has two positions. It's a pretty simple tool. It has a work position and a reset position. So we'll show you the reset. Right now, I've tightened it down to work. You just need to give it a firm thing. I'm going to stick this through. Get it in camera here so you can watch. Okay. As you're working, you want to keep the wire firmly pressed into the terminal so it doesn't slip out or expose any wire that can cause problems later. And this, when that gap is closed in the die, okay, when the gap is closed, that's as far as it's going to go. Okay, so that's all the way down. Now, to release it, I've got to turn the knob right here counterclockwise to the reset position, and it snaps back into place. Okay, there's my terminal attached. I'm going to give it a good tug. It is really on there. Okay, now I'll slide the heat shrink up. Later, I'm working back in the van where I don't have 110 volts right now, so I'll go in the shop in a few minutes and do the shrink this heat shrink tubing down so it covers the terminal. Again, that minimizes chances of shorts. You're working with heavy DC current like this, you don't want shorts. Okay. So the next trick is to determine the length. I'm going to do that. Let's see. You want these cables to be about the same length, so make sure this is these match in lengths. So I'm going to make this cable the same length as the red cable. The more evenly the cables introduce, let me go to basic. Okay. Whenever electrical current flows through a conductor, there is resistance. That's a conductor. If you have a superconductor, there's no resistance, but we don't have superconductors. We have conductors. Every conductor has resistance, and that resistance creates heat, and that heat is wasted energy. So if we use wire that's too small, not only is it in danger of catching on fire, but it has, the smaller the wire, the more resistance it has, the more heat it creates. That's why it may melt something or catch something on fire, but it also wastes energy. So every inch of cable that we have is using at least some amount of energy, turning energy from our battery, from our solar system, from our car engine, wherever we charge these batteries from. Our battery power is being wasted as heat if we use cables longer than necessary. So I'm going to cut, and also we want these batteries to stay balanced with each other. Another good reason to keep the cables the same length. So we want to try to keep the total length of cable the same. I'm going to line these cables up here. Straighten them out. Check the length. I'm going to mark this right here. And get my cable cutters. These came with this kit. This is about $48. This is an Amazon deal. Next day shipping for free. That was kind of nice. So, you take these cutters. You want to cut horizontally across. You want to make sure you have a nice straight cut horizontally. And with one hand, I'm able to cut that. And you can see what a nice cut it makes. Okay, don't know how close I can get with this camera. We'll figure that out in post, I suppose. So my heat shrink's already on. Make sure that I have a 5/16 to match the terminal post. Make sure I have a 5/16. Going to look at how far that's going to go in. cut this. Careful with your fingers and careful with the conductors. You want to cut rubber, insulation. You do not want to cut conductor. Make a long slit. Actually, that's just going to pop right off. Okay, I see 0 conductors in there. So again, did a nice job, didn't cut any conductors. Heat shrink is on. We have the right size. We have the terminal matched. I'm not using one of these 3/8 terminals. I'm using the 5/16 terminal that matches my post. Okay, so you're matching that to the post. Sticking all the wires in there. And then we're going to do the same thing again. Oh, but again, we're going flat to flat. So I want to put this down on the floor. Make sure they're both flat. And I want to take my marker even though this cable is a little bit flexible, I still want to make this mark. So I've made a mark on there so that when I crimp, if these two marks line up, this will be flat to flat, and I won't have to try to twist a very hard to twist wire. So, important lesson. Pretty much everything I'm talking about here is important. Everything I've discussed needs to be done right. This is not a job you want to mess up. This cable's very expensive by the foot. It's about $13 a foot for cable. So mistakes are expensive. So we've set the crimper to its working position. We'll bring it down till it's snug. Okay, what I'm doing is, okay, now I've gotten this snug. I've lined up the marks, and now that it's snug, I start with takes a little bit more pressure. This crimper is actually a real pleasure to use. Once I figured out I needed the smaller die because of a softer cable. And I'm going to crank this all the way down. It's nice and tight. Now I turn it from work, release, and it releases. Okay. Now I'm ready to complete this part of the job. I'm going to start by putting the positive cable first. Once these terminals are torqued down, okay, now the positive cable is connected together. And let me find my screwdriver. Let's take these negative terminals. All right, oops. There we go, drop that one. Okay. So now, take the first terminal. Okay. And okay. I'm going to pull this away from the positive terminal just to reduce any chance of a short. Don't want an internal short in this. And so these two batteries are now connected in parallel. These two 12-volt batteries are still 12.8 volts, but It's 100 amps plus 100 amps. These are now 200 amp batteries. Batteries can be wired in series. If I'd chosen series, I would have wired it differently. You can look that up on the internet. But I would have wound up with 24 volts instead of 12 volts. And I still would have had 100 amps. But 100 amps at 24 volts is twice as much power as 100 amps at 12 volts. The total wattage, that's your real measure of power. The total wattage you get is the same whether you wire in series or parallel. One advantage of wiring in series would have been I could have used smaller wires. I could have used wires half this size, because the higher the voltage is, the more power there is to push past the resistance. And so you can use smaller wires when you have higher voltage. That's why we have 110 and 220 volts in our houses instead of 12 volts. It would take a massive amount of wire to run everything on low voltage DC current. Okay, so we've just wired these two batteries in parallel, and the final step is when we connect these batteries out, we'll bring them out to a bus bar, but we'll bring the positive wire here. We don't want to put the negative here because that can leave these batteries unbalanced. So again, we're going to put the negative wire on the other battery. So this is battery number 1, this is battery number 2. So you use the positive wire of battery number 1, use the negative wire of battery number 2. I'll bring these out, and in another video I'll show you further steps in completing this. I'm going to put a sheet of plywood over here. I'm going to cover these batteries up. I'll put some holes, and I'll poke the new wires, the new positive and the new negative, like this. They're going to come through. Again, I'll cut these wires to the same length. They'll meet someplace in the middle here, and they'll go into the bus bars, and then from the bus bars we'll go on and hook everything else up. But that's another lesson for another day. But this is how you wire batteries in parallel and wind up with 12 volts, 200 amps of power. Hope that's going to be enough power for everything I need. So that's it. I'm Dan. I like to fix things. I also like to build things. I like working with electricity. I've done it my whole life. I've been able to do most of my own electrical work on my home and my cars, and I like doing electrical. It's a lot of fun. So I hope you enjoyed the video. I really hope that you'll hit the like button, thumbs up, give it a thumbs up. That tells YouTube that you guys like what I'm doing and you want to see more of it. That's a good thing for you, me, and YouTube. I'll take this apart, take this in and heat shrink it, put it all back together. This part of my electrical build will be done. So that's it for today, actually tonight. And that's it for me right now. I'm Dan. I'm Dan at Dan Fixes Everything. And I'll see you down the road.